Okay, so now this is the second video, part two, and on the last video, I left you with when is the particle moving forward in the positive direction. So, in other words, v of t, remember that velocity represents direction, so we want to know when is that positive. So we have our velocity function. Hopefully I won't run out of room. And we set that greater than 0. Well, we can factor out a 3 to make life a little easier for us, if I can factor correctly. So that'll be t squared. We divide 12 by 3, we get minus 4t, and then plus 3. And I'm going to go up here. And so this is greater than 0. So then we have 3, and we can factor that to t minus 3, t minus 1, greater than 0. And so that tells us, all right, so now we have to think for a minute because we want to know, well, when is this greater than 0? Well, you can just divide that 3 on both sides right there and get rid of that 3. So that 3 is irrelevant when we're solving for this. We're really looking at this portion right here. When is t minus 3 times t minus 1 greater than 0? Well, remember, in terms of numbers, we know when we multiply two numbers, they're positive. If the two numbers are positive, when we multiply them together, we'll get a positive number. But also, when two numbers are negative and we multiply them together, we get a positive number. So the answer is when t minus 3 is greater than 0 and t minus 1 is greater than 0, or t minus 3 is less than 0 and t minus 1 is less than 0. So I want you to actually finish this and tell me, so here, on what two intervals would that represent? Okay, so you can solve their linear expressions, so you can solve those, or linear inequalities, so you can solve those two and figure that out. Okay, so that's the end of 3.4. All right, so now moving on to 3.5. Okay, so what I would suggest now is that you pause the video and fill in the blanks on your sheet and then play it, because I'm just going to go through this rather quickly. Okay, so now we're getting section 3.5. It's rather a short section, so it shouldn't take us too long. It's dealing with higher derivatives. So we've talked about derivatives. And again, remember, derivatives is a rate of change. When you take the first derivative, it's the rate of change of something. It represents the slope of the tangent line at some certain values. Okay, so for higher derivatives, this is obtained by repeatedly differentiating a function. Okay, and if f prime is differentiable, okay, remember that was my abbreviation for differentiable, then the second derivative is denoted by f double prime. I'm sorry, you probably that's a double prime. So f double prime. Let me change the color. That's f double prime of x or y double prime, okay? And the second derivative definition is f double prime of x equals the derivative with respect to x of f prime of x, okay? And you can continue the process of differentiation as long as your derivative exists. So as long as you have your derivative exists, then you can continue differentiating, okay? And actually, in general, the nth derivative is the derivative of the n minus 1 derivative. Okay, so now that we know, as long as we keep having a derivative, or as long as the derivative exists, we can keep differentiating. So this first example is calculate f triple prime of negative 3. Okay, so to do that, all right, so we have to take the derivative, then take that derivative, then take that derivative. Okay, so for this function, so f of x, we could just start by writing our original function, equals 4 times e to the x minus x cubed. So f prime of x equals, well, remember the derivative of e to the x is just e to the x, and that constant stays there, right? Because we talked about the constant rule with derivatives. So that's just going to stay 4 e to the x minus x to the third. We can use our power rule, so that's 3x squared. Good. Then f double prime. Okay, so that's the derivative of All right, so that's the derivative with respect to x of f prime of x, which in this example, that 4e to the x is just going to stay there. That 3x squared will now become 6x, okay? And we need to take one more. The third derivative will be, it will just be the derivative of that. So again, we're going to be left with 4e to the x minus 6. Now, we're not done because the question asks us to calculate f triple prime of 3. So f triple prime of negative 3, equals 4e to the negative third minus 6, right? And we can just rewrite that as 4 over e cubed minus 6, okay? And we're done. Don't ever approximate, and this for WebAssign as well, don't ever approximate if it's not telling you to approximate. Okay, so actually just do the time example too. It's in your book. So I want you to copy this example down from your book and see if you can figure out their formula. What I will say is to give you the definition of something that you might not have seen before. You may not have seen before. It's called n factorial. Okay, this is n factorial. So that exclamation point means factorial. And the definition of n factorial is n times n minus 1 times n minus 2 ... It goes all the way down to times 3 times 2 times 1. And it's a useful property, and you'll see this again in Calc 2. But for example, 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1, just 2, and so on. So you'll need that because they talk about that. But what I want you to do is actually look in your book and follow that example. It's not called example 2 in your book, I don't think, but it's in this section 3.5. Okay, for the sake of time, I want you to do this one on your own. So do on your own. Okay. All right, so again, I'm going to write some information down. So if you want to pause the video and fill in the blank and then listen, that would be good. Okay, so Galileo discovered something as an object is tossed. The velocity, and that is not correct. It's tossed vertically. I'm jumping ahead. See, I still make mistakes in videos. Okay, so he discovered that if you toss an object vertically near the Earth's surface, he had a formula for it where S sub t equals S sub naught, that's S sub naught, which is the initial position, plus V sub naught, which is the initial velocity, times t, which is time, minus 1/2 times g times t squared. And note that negative g is the acceleration due to gravity. Now, that is denoted by 9.8 meters per second squared, and it's negative on the Earth's surface because the up direction is positive, because, gravity pushes us down. So the up direction is going to be positive. So gravity is pushing us down. That's represented as negative. But if we throw something up in the air, then we're fighting against gravity. So that's going to be positive. And also note that when you set V of t equal to 0, that represents the max height of an object. And I'm going to stop this video now and continue. And the last video will be very short.